Let's practice finding the volume of a rectangular prism with various unit cubes together. Given a set of dimensions of a rectangular prism, what we're going to do is go ahead and draw a 3D figure. Let's go ahead and label each of those dimensions, the length, the width, and the height, and then we're going to go ahead and calculate the volume while we're at it. Once we're done doing that, what we're going to do is figure out how many 1 by 1 by 1 unit cubes are going to go inside this prism, as well as half by half by half, and third by third by third. So smaller and smaller and smaller cubes that are going to fit inside of this rectangular prism. And then finally at the end, we're going to go ahead and prove that despite the different size cubes that we're going to fill up the rectangular prism with, the volumes of them are still going to all be the same when you put them all together. The length of this rectangular prism is going to be 3 feet long. The width is going to be 4 feet wide. And then we're going to go ahead and have a height of 5 feet. Let's go ahead and start sketching this out together. Alright, so here is a sketch of this rectangular prism. We have a length and width of 4 feet each, and we have a height of 5 feet. 3 and 4 are each going to represent the length and width, while 5 is going to represent the height. Now that we have a sketch of this rectangular prism, let's go ahead and figure out the volume. So that volume formula for prisms is going to be capital V for volume. That's going to be equal to capital B, which is just the area of the base, multiplied by lowercase h, which is just the measurement of the height. Okay, so in this case, B is going to be created from the product of L and W because the base is a rectangle. So we're going to have length times width multiplied by height. And if we make some substitutions here, the length here is going to be 3 feet. So I'm just going to go ahead and substitute in 3. The width here is going to be 4. So I'm going to substitute in a 4 here. And then the height is going to be 5. So I'm going to multiply this by 5. Multiplying these all together, 3 times 4 is 12, 12 times 5 is going to be 60. So we're going to have a total volume here of 60 cubic feet, or 60 feet cubed. Okay, so now that we know what the volume of this rectangular prism is, let's go ahead and see if we can figure out how many 1 by 1 by 1 foot size cubes would fit inside of this rectangular prism. Alright, so I'm going to start by just drawing a unit cube to see what that would look like. So I'm going to draw a square, and then draw some dimensions that would make all the sides, or the faces rather, a square. So this is going to be 1 foot by 1 foot by 1 foot. So the question is how many of these little cubes would fit inside of the entire prism to the left? Now let's talk about how we can figure out how many of these 1 by 1 by 1 foot cubes would fit inside of this rectangular prism, and I'll do that using 2 different methods. For method 1, we can take the total volume of the rectangular prism and divide that by the volume of one of these cubes. Now we already know the total volume of this rectangular prism is 60 cubic feet, so we can go ahead and say that this is going to be 60 feet cubed. That's the volume of the entire rectangular prism. But what's the volume of one of these little cubes? Well, volume, again, is going to be length times width times height, but this is just going to be 1 times 1 times 1. So the volume of this one little cube is going to be 1 foot by 1 foot by 1 foot, or 1 cubic feet, right? So 1 cubic foot. So we can go ahead and divide the 60 cubic feet and divide that by 1 cubic foot. So if we go ahead and do that, then 60 divided by 1, or we can write this as a fraction as well. But 60 divided by 1 is just going to be 60. And then feet cubed divided by feet cubed are going to cancel out. So they're going to be 60 of these little cubes. So taking the total volume of the rectangular prism and dividing it by the volume of one of these cubes, we get how many of these 1 by 1 by 1 cubes fit inside here. Here's method 2. For method 2, let's just see how many of these cubes would fit in each of the dimensions of the rectangular prism. So we know that we have this 1 by 1 by 1 cube here, so go ahead and take a look at the length. The length is going to be 1 foot, and so we're going to see how many of those would fit across the length of this actual rectangular prism. So we're going to see how many 1s fit into 3. So let's just take a look at the length first. So if we take a look at the length, okay, then we know that the whole entire length is going to be 3 feet. So let's go ahead and write 3 feet. But if we go ahead and divide that by the 1 foot that we know is going to be the length of one of these little cubes, if we see how many fit across just going through the length there, then we're going to say that that 3 divided by 1 is going to be 3. So we're going to have 3 cubes that'll fit across the length of this rectangular prism. Okay. Now what about the width? Well, the width of this little cube is just 1 foot. So how many of those would fit across in the width, which is going to be 4 feet here, right? So the width here we know is 4 feet for the rectangular prism. And we want to see how many of these 1 foot by 1 foot cubes fits alongside there. So we're going to divide it by 1. Now 4 divided by 1 is just going to be 4. So we're going to know that 4 cubes, or 4 of these 1 by 1 by 1 foot cubes, would fit across the width here. And finally, what's the height of one of these cubes? Well, it's just 1 foot, right? Hopefully we can predict that. And we want to see how many we can stack on top of each other going up and down along the height here. So we have the height. We know that's going to be 5 feet for this particular prism. And we want to see how many of these fit inside. So let's go ahead and divide it. We know the height of one of these cubes is just 1 foot. And so 5 divided by 1 is just going to be 5. And then feet divided by feet cancel out. So we just have 5, and it's 5 cubes. So if we want to find the total number of cubes, what we're going to do here is just multiply along the bottom. We know we have 3 by 4. So we can go ahead and take this 3, and we can go ahead and multiply that by 4. So that's going to be 12. There's going to be 12 cubes on the bottom. Then finally, we're going to multiply that by 5 layers of that. So multiplying that by 5, that's going to be 60. So it's going to be 60 total cubes. Now hopefully this makes sense and lines up with what we did with the volume, because when we do volume, that's specifically talking about these 1 by 1 by 1 unit cubes. So it's going to get a little bit more interesting when we talk about the other sized cubes. Alright, so while that's the 1 by 1 by 1 feet cubes, let's go ahead and take a look at the half by half by half ones. And these ones are a little bit trickier to understand. So let's start by just sketching out a little cube first. So this time we're going to be filling up the rectangular prism with these half by half foot cubes. So they're actually much smaller than the ones that we were dealing with earlier, so we should be able to fit more of them inside of the rectangular prism. So let's start with method 1 again. For method 1, we can find the total number of these cubes that fit inside if we take the total volume of the prism and divide by the volume of one cube. So we know the total volume of the rectangular prism was going to be 60 cubic feet, right? We found that out earlier. But what was the volume of one of these particular cubes? Well, volume of this cube would just be length times width times height, or it's going to be half multiplied by half multiplied by half. So in the numerator, 1 times 1 times 1 is still going to be 1, and in the denominator, 2 times 2 times 2 is going to be 8. So the volume of one of these little cubes is actually 8 times smaller than one of the original 1 by 1 by 1 foot cubes. Now it's important to note that the volume of one of these cubes is actually 8 times smaller than the little cubes we were using earlier, and that's because we took half of each length in each dimension. So half times half times half is an eighth of the size of a regular 1 by 1 by 1 cube. Okay, so the volume of one of these little cubes is 1/8, so it's 1/8 of a cubic foot. And so that's the volume of one of these little cubes. So if we go ahead and do that division here, that is going to end up being what? That's going to be 60 divided by, which is going to be multiplying by the reciprocal, and the reciprocal of this 1/8 is just going to be 8 if we keep change and flip. And so 60 times 8, that's going to end up being 480. So if we were to fill up this prism with these half by half foot cubes, we would be able to fit in 480 of these, or 8 times more cubes than earlier with the 1 by 1 by 1 foot cubes. Here's method 2. So for method 2, let's see how many cubes would fit in each of the dimensions. So just like we said earlier, the length was what? The length was 3 feet for the prism. And we're going to see how many of these halves fits across there. So if we look at this half, this dimension going across this half, we want to figure out how many of those halves are going to fit across into 3. Right? So in order to do that, what we're going to do is take this 3 feet, and we're going to go ahead and divide it by the half to see how many are going to fit in. And if we go ahead and do that, we're going to see that's going to be 3 divided by, or we're going to turn that into multiplication. So we're going to multiply by the reciprocal. So it's 3 times 2, and 3 times 2, that's going to end up being 6. So we can fit 6 of these cubes going across the length. Now what about the width? Well, we knew the width here was going to be 4 feet. So we want to see how many of these fit across. So we're going to take this 4 feet and divide that by half, because we're fitting in these half by half foot cubes. And so that's going to turn into 4 multiply, because we're going to keep change and flip and multiply by the reciprocal, which is 2. So 4 times 2, that's mean that we can fit 8 of these cubes in the width. And then finally, what's the height of the prism? Well, the height we knew was 5 feet. And if we're trying to see how many halves fit inside of it, well, if we divide by half, then we're going to end up multiplying by the reciprocal, right? So we're going to multiply this 5 times the 2. And we should be able to fit 10 of them, I think, right? So 5 times 2, that's going to be 10 cubes are going to stack on top of each other nicely. Now to figure out the total number of cubes here, we have 6 going across the length multiplied by 8 going across the width. So 6 times 8, that's going to be 48 across the bottom. And we're going to have 10 layers of this. So 48 times 10, that should get us this 480. And that's going to be how many cubes? And this should match what we found earlier as well. So just another method to get the same answer. Alrighty, one final scenario. Now let's take a look at these 1/3 by 1/3 by 1/3 foot size cubes, and these are even smaller than what we had before. Let's start by creating a sketch of one of these little cubes. Alright, so I know I'm drawing all of these unit cubes the same size, but it's just because it's kind of hard to draw them extra small. So imagine this is even smaller than the last one. I'm just drawing it so we can see what's going on here. Now, hopefully you're getting used to the methods a little bit. So I'm just going to start by finding the volume of one of these just because it's going to be helpful. So if we're fitting these 1/3 by 1/3 by 1/3 foot cubes inside here, to figure out the volume, we do length times width times height. 1 times 1 times 1 is going to be 1, and 3 times 3 times 3 is going to be 27. So the volume of one of these little cubes is actually 27 times smaller than one of the original 1 by 1 by 1 foot cubes. Okay, so that's the volume of one of these little itty bitty cubes. Let's try method 1 for figuring out how many of these little cubes would fit inside of the original prism. Remember that we're going to take the total volume of the prism, which is going to be 60 cubic feet, and let's go ahead and divide that by the volume of just one of these little cubes, and that's going to be 1/27 cubic feet. Again, these are much smaller, and so if we go ahead and divide these, we're going to keep the 60, and we're going to go ahead and multiply by the reciprocal here. The reciprocal of 1/27 is just going to be 27, and so 60 times 27 is going to be 1,620. So filling up the original rectangular prism with these even smaller cubes, these 1/3 by 1/3 by 1/3 foot cubes, we can fit over 1,000 of them, 1,620 to be exact, of these cubes would fit inside of the rectangular prism. Alright, now here's method 2, where we go ahead and figure out just how many of these cubes you can fit on each of the dimensions of the rectangular prism. And so we know the dimensions of the rectangular prism, and if we want to see how many of these 1/3 foot cubes are going to fit inside of each of the lengths or the widths or the heights, let's go ahead and divide and see how many times 1/3 fits into that 3 feet going across the length there. So if we do that first one, 3 divided by 1/3, that's just going to be 3 multiplied by the reciprocal. Reciprocal of 1/3 is 3, so that means we can fit 9 of these cubes across the length. Okay, and then for the width, what we're going to do is we're also going to divide by a 1/3 here. So let's see how many thirds fit inside of 4 holes. So 4 multiplied by the reciprocal, that's going to be 4 multiplied by 3. That is going to be 12 cubes going across the width. Okay, and then so finally for the height, if we want to see how many of these 1/3 by 1/3 by 1/3 foot cubes fits up and down, if we stack these on top of each other, how many times does 1/3 fit into 5? Well, that's going to be 5 multiplied by the reciprocal, which is 5 times 3. And so 5 times 3 is going to equal 15. So we're going to have 15 of these cubes stacked on top of each other. Across the bottom, we're going to have 9 of these little cubes multiplied by 12 going back along the width. So 9 times 12, that's going to be 108 across the bottom. And there are going to be 15 levels of this, or 15 layers of 108. So 108 times 15. So multiplying how many of these cubes go in each of those dimensions, we figure out we have 1,620 of these cubes in total, which hopefully makes sense that as the cubes got smaller in each of these examples, that we got more of them because you can fit more of these smaller sized cubes inside of that original rectangular prism. So there you have 2 different methods for figuring out how many of these different size cubes would fit inside of the original rectangular prism. You can use this method even with other different size cubes as well. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.